Good afternoon. Welcome to this session on how to automate code modernization at enterprise scale with agentic AI. My name is Elio DiMaggio. I'm a senior manager of product in AWS Transform Custom. Here with me is Morgan. Morgan Lund, he's a senior product manager and main partner in crime for this product that we're going to talk about today. Unfortunately, Shriram is not able to be with us today. He's our director. He has a press event that could not move. Before we get started, how many people here have problem with tech debt or modernization? Okay. Well, what we're going to talk about is that we're going to talk about technical debt in this presentation, and the challenge that we have is actually very pervasive. Everybody that we talk to has this issue. Morgan is going to talk a little bit about how to get started with AWS Transform and how to perform transformations at scale, because transforming and modernizing a single repo is more kind of a proof of concept instead of actually addressing your tech debt challenge, which usually spans hundreds, if not thousands, of repos. And after that, we're also going to talk about customization, because what every customer that we talk to has organization-specific challenges. Even things that are common, such as Java upgrades or Python upgrades or dependency upgrades, they tend to have specific challenges that are unique to each organization. Then we're going to talk about value and pricing. So let's talk about technical debt. 20% of IT budget is currently spent trying to address technical debt. That is a lot of resources that would actually be spent in innovation. And that's actually probably like a lower estimate. 23% of developer time is lost because there is tech debt. That is not the time that is spent to address tech debt. That is lost because you have tech debt, dealing with older frameworks, dependencies, trying to figure out what to do. Accenture estimates $2.4 trillion of tech debt costs per year in the US alone. Of course, tech debt comes in many forms. There is security and compliance risk, your end-of-life runtimes. Many customers have Lambda running on end-of-life runtimes that are going to be deprecated this coming year. But even without Lambdas, you probably are still running applications on Java 8. There's lots of stats that many customers are in that situation. Similar thing for Python and nodes. You may have vulnerable libraries, things for which vulnerabilities are known, and they're hard to migrate from. These are usually things that are harder than just going in a config file and bump up version. There's maintenance burden. You have unsupported framework that you have to start supporting yourself. You may have legacy patterns that you have to support and skill your developers in these patterns that you don't really want to use anymore. There are performance limitations. You may leave performance and spend higher operational costs because you're using older versions of older libraries and frameworks and things like that. You may also be miss out on modern features. Finally, there's strategic misalignment. Usually what happens is that as a result of merger and acquisitions, or just organically, your different business units and teams end up like using different versions of tech stacks. And that is a drag on your innovation. Now, of course, many companies address tech debt in a manual way. Fundamentally, they just treat it as any other software development. There's specs, their development, you track them in your issue tracker, and you just go at it. There are ways to make things better and to try to automate. The existing approaches are rule-based automation. Think about AST, grep, OpenRI, tools like that. They usually require specialized expertise to run. They tend to be brittle and inflexible. you have a rule-based code modification recipe or rule, and that works for that specific case, and if things are different, there's usually a lot of cleanup that has to happen after that. There's usually a lot of startup cost, and it's really hard to customize them for your case. They also have a much more limited scope. There's only so much thing that you can do with deterministic rules. In the end, you're basically writing a program that modifies a program in abstract. Really, really hard. There are general purpose coding AI, and there's many of them. These are usually focused on an interactive execution. There's a developer that's using them. It's an assistant, great acceleration. They're great products. They're, however, less suited for autonomous execution. And in the end, we do not want your developers spend time to do this kind of modernization. You want to automate it. There's also no easy way to organize reusable knowledge. Usually what happens with this modernization, they affect multiple teams in a similar way. And with a general purpose coding agent, every team has to organize the knowledge to do the modernization by themselves, and there's no way to share the learnings across these teams. Now, what we really want is that we want a low barrier to entry. We want a tool that's designed for automation. We want to be able to learn once and use in every situation where that transformation or modernization challenge happens, and we want the tool to be able to improve continually. So let's look at a little at some of the transformation challenges that our customer had. We've had our product in beta since April of this year. And we work with many customers internally and externally to tweak our product and make sure that we could provide value. Air Canada here had a problem with Lambda upgrades. Node.js 16 was basically coming end of life, and they had very tight security deadlines to make sure that they got off of that. They also wanted to migrate to Graviton instead of x86. Internally, our friends at Twitch, they were still running on AWS SDK v1 on their Go repos. They had more than 900 repos running on it. There was an enormous task to basically upgrade across all of these repos. Quad is a manufacturing company. They wanted to migrate all of their customers with each own with their custom plugin with their previous platform to their new platform. So they wanted to translate their very specific progress plugin into their new DSL. This is a very complex modernization project and definitely very organization specific. We also work with MongoDB that is working on how to help their customers migrate off of older versions of the MongoDB SDK and adopt new functionalities. Let's take a step back. In May, we GA'd AWS Transform and supporting modernization workloads specifically for VMware migrations, full stack Windows modernization, and mainframe. Yesterday, we launched AWS Transform Custom. This is a product that allows you to transform any code pattern. It has built-in transformations, or you can create your own. It supports diverse scenarios like version upgrades and runtime, up to language transformations. It does have continual learning and improves, and it scales transformations to enterprise-wide scale. What are the main components of AWS Transform Custom? You can define transformations with natural language. You do not need specialized expertise. You have natural language prompts. You can provide code samples of what you want to do, migration guides, documentations, whatever you have. Then you can execute them at scale, either through a command line, interactive, or integrated in your CI/CD pipelines. We support multiple ways to integrate it into your own flows using your own environments. And of course, it enables campaigns across multiple repos. Finally, and very importantly, it learns from developer feedback. So when your developers are modernizing your repos and they provide feedback to the agent, that feedback is captured and reused for the different executions. Not only that, Also, the agent learns by applying the same transformation over and over on your repos. So if it tries an avenue of transformation and finds out that test doesn't work and doesn't work out, it will not try that again later. Of course, all of this learning can be controlled and access controlled, and the idea is that you can define a transformation once and reuse it across many teams and many repos. That is different than just reusing a migration guide or every team interactively using coding agents. We also provide AWS managed transformations for very common scenarios. Java runtime upgrade, Python runtime upgrade, Node runtime upgrades, AWS SDK upgrades, and we also have a few of early access ones, tech debt analysis and x86 to Graviton for Java. These transformations are zero setup. We validate them on very, very wide benchmark suites, and we're continuously growing the number of transformations that we provide natively. We also, and importantly, allow you to build your own. The common use cases where we see this being very, very useful are API and service migration, of course, language upgrades for things that we don't support, framework upgrades, code refactoring, custom patterns, and things like that. The idea here is that you can create, you can instruct the agent to execute the patterns that are unique to your organization. At the end of the beta, Air Canada was able to achieve 90% efficacy rate for the conversion of thousands of Lambda code bases, and 80% reduction in expected time and cost. And they're basically are making this product part of their operational, part of their internal standard. Quad was able to enable projects that would take 2 weeks into projects that took just 3 days, achieving 60 to 70% production gains and saving an estimated 7,500 developer hours annually. This is to convert all of their customers to their new platform. Twitch achieved 70% acceleration on each application migration. For 913 repos, they're projecting savings of nearly 11 developer years. Finally, MongoDB was able to demonstrate a big impact in modernizing and migrating Java applications specifically for the MongoDB APIs. Now, I'm going to give it to Morgan to tell you how you can get started with AWS Transform Custom right away.
Thanks, Elio. So the team that built Transform Custom was very deeply involved in the initial AWS Transform release and in the release of Q Developer, and we learned some lessons along the way. One thing we learned was that onboarding on those services was harder than it had to be. So some of them required identity center setup and connection of your federated identity provider to AWS, which had all sorts of security approvals that would need to go through. You can get started with Builder ID for Q Developer, but then there wasn't a good way to graduate up to an enterprise subscription. So we tried to do away with all of that as much as we could with Transform Custom and really cut to the bone the bare minimum needed to set this thing up. So there is no human identity. It's all IAM permissions, just like any other AWS service, meant to be machine-driven. Of course, humans can use it as well, and I'll show you how to set that up in a moment. Standard AWS infrastructure, security, access control, stuff that you already know how to use. We're not trying to reinvent the wheel here. The setup is quick and easy, and I'll show it to you in a sec. It's like literally a one-line bash script to pull down our installation script and execute it. And then you configure your permissions just like you do with the AWS CLI. It works with your build system, with your existing tools. The transformation execution is happening locally on your device, so you don't have to try and recreate your complex build environment in the cloud if like some other services would have you do. And it's super easy to compose this as a part of your broader modernization workflow. So you can write a script to pull down your code from wherever it is, execute a transformation, push it wherever it needs to go, whatever you want. It's meant to be composable, flexible, an engine that you can stake and put in the car that you're trying to drive. So I said it's easy to install. That's it. That's the command. You can go find it on our docs page. That pulls down the package, executes it, installs it. We have 2 dependencies. You need to have Node.js installed, and you need to have Git installed. And that's about it. and it works on Linux, Mac OS, and on Windows through WSL. No native Windows support at this time. We're working on it. So this command line has human interactive mode as well as a machine drivable mode. So in human mode, you have a friendly conversational agent that asks you, hey, what is it that you want to transform? It'll query our registry to find, is there an existing transformation that does this, or am I going to help the user to build a new one? And it has all of our best practices encoded in it. So when you're trying to create a new transformation, you don't really know what you need to provide the agent. Like you want to go from API A to API B, the agent's going to extract from you like, well, if you have documentation for those APIs, that would be helpful. Or if you have a migration guide, maybe you wrote for human users, that would be helpful too. Based on our several months of beta we've run here, we've come to some really crystallized best practices, and we put that right to guide you the right way. As I mentioned, the command line can be also driven machine mode with a totally deterministic syntax. So you put all the arguments up front, and you hit go, and it's going to execute your transformation. No human involvement needed at all. The benefits to this is it's quick to start. It's quick to start getting feedback. It's quick to figure out if this is going to work for you. And ideally, if it doesn't right away, transform custom, right? It's meant for you to tweak it, for you to add your own customizations. If you've got organization-specific requirements or libraries or dependencies or coding conventions, you can teach it to this thing, and it'll remember it and use it as it transforms your code. So as Elio mentioned, we have some out-of-the-box transformations that we give you. Java, Python, Node runtime upgrades, AWS SDK upgrades for those languages as well. A tech debt analysis, which I think is super cool. That's something we got squeezed in at the last minute. Basically, it does like a complete, thorough documentation of your code, all of the relationships between the various functions in there, data flow diagrams, entity relationships. Think of it like the most comprehensive code documentation you could imagine is what we try to generate there. And then we use that information to distill out an analysis of tech debt and suggestions for things you may want to modernize. There may be libraries in there that you didn't know how to or you didn't know were deprecated, and we try to surface that to you. Now, that's early access. It's not perfect yet. We're still working on it, but we're comfortable enough to give it to y'all to try out. Java x86 to Graviton, we're seeing really good success on our benchmarks internally on that. That one's hopefully going to leave early access relatively soon once we have a little more data. And of course, if you have to do something beyond this or in conjunction with these transformations, you can build your own. You can upgrade your Java, and you can replace library A with library B. Or you can stick these things together and mix and match to solve the problem that you're really trying to solve.
Is there a community set up for providing transformations?
So there is not an official community thing set up yet. It's something we've really talked about. And when we talk about transformation definition portability in a minute, we'll come to that. But one of our tenets is you spend the time and effort to build a custom transformation, and as far as I'm concerned, that's yours. You can keep it secret, you can share it with the world, that's up to you. And we try to make these things import and exportable as we can. So let's see how easy it is to get started. Oh, do I?
Just press.
Ah, look at that. So what you see here is I put that command in, I run it, it's installed. That's it. And now I type ATX, which is the three-letter command to kick this thing off. There's the help menu, and there's our cool ASCII art that I designed. So I'm telling the agent, hey, I want to create a new transformation. I want to upgrade my, what am I doing here, Python repos? Yeah, that's what I'm doing. And it's going to search through our registry, and it's going to say, hey, it looks like there's an existing transformation built by AWS out of the box already to do this. You want to use that one? And I'll say, sure, because it's a totally agentic chat. You just talk to it. So it's doing some prerequisite checking here, making sure Git is initialized on the repo that I pointed it to. And finally, it's going to ask me if I have any special requests. Like you're at a restaurant and they're like, hey, you want the burger, but do you want onions? You can give it your extra little special request here, which it's going to incorporate during this particular transformation execution. And it's off. It's running. It's doing its thing. It'll take 10, 20 minutes, depends on the size of the code base and stuff. But that's how easy it is to get started, to install the CLI, to point it to an existing repo you have on disk, and just start transforming it. Scaling up. So, okay, pretty cool. I can transform one repo, but I've got 500 repos I need to transform. How do I do that? So based on our beta experiences with our customers so far, we found certain patterns that seem to work well that kind of map to different people with different jobs within a large organization. So first thing you want to do is plan. Figure out, what do you want to transform? Do you want to upgrade your Java runtime? Do you want to migrate from Dropbox to Box because your company signed a new deal? Did you acquire another business and they use some API provider and you have a different one that you use as a standard and you want to migrate their code to use that? Figure out what it is that you're trying to transform. And then you're going to identify some representative targets to start with. So a code base that's not too simple, not too complex, something that you feel like kind of hits the mark of a good representation of all of the other code bases you're going to have to transform that are facing the same problem. And then you try it. You sit down with our agent, like I just showed you. It asks you, what do you want to transform? You tell it, I want to go from blah to blah. Here's some documentation. Here's a how-to guide I wrote for human users. Here's a blog post. Here's you can really feed it any text that should be helpful. Code diffs, if you've done it before in a few repos, those are really helpful to actually show, not tell the agent what you're trying to do. So you do this, you create your initial transformation, and you'll notice here this is done by a centralized team. So one pattern that we found works well, especially at large companies, is when there is a kind of a core central team in the organization who's responsible for coding standards and conventions and practices, they tend to be the ones who go about creating these transformations so they can disseminate them out to the application owner teams who are actually going to run them. So after you've created your initial transformation, start a pilot. Do it with tens of apps. And you'll start to collect some data on like, okay, how long does this take to run? How good is it? Does it hit 70% efficacy? Does it hit 95% efficacy? Just depending on the complexity of what you're trying to do with it. And you can also get a really good idea of what it's going to cost here. So Elio is going to talk about pricing in a little bit, but it's purely pay-as-you-go, totally usage-based, no subscription stuff at all. And it's based on how much the agent is working. So a more complex transformation, agent works more, it's going to cost a little more. So through the pilot phase, you'll collect data on that, and you'll be able to budget, okay, to do this campaign, it's going to cost us roughly this much money. And then you can start to scale it out. So I'll talk in a minute about the push modality and the pull modality, which are the two different ways of doing these sorts of campaigns that we've seen. You integrate it with your source control if you would like to, and you can monitor and make sure the progress is going as you would like. And then the most exciting part about all this, in my opinion, is the learning. So every time a transformation executes, our agent goes and checks all of its work, looks at everything that it did, and identifies knowledge items, things that it wishes it knew at the beginning of the transformation that'll make it faster, better, do what the human actually intended for it to do, and it's going to incorporate that information next time it runs. The benefits of doing this in a centralized approach, like we're talking about here, is that you only have to put in the effort of defining this transformation one time. The quality is going to be consistent. Everyone across your organization is going to have the same thing done in the same way. Like if I were to write a wiki page telling everyone in my company, hey, we're migrating off this old ticketing API, you need to use this new ticketing API, and I send that to a bunch of application owner teams, A, getting them to do it, it's going to be hard unless there's a top-down mandate. But B, there's a decent chance, just because humans are humans, everyone's going to interpret the words in that wiki a little differently, even if I try to be really explicit with it, and they may follow different conventions and do things differently. With a centralized transformation approach where you define once and you run many times, you can be confident it's going to be done roughly the same way each time. And finally, we break down those knowledge silos. So if you have a bunch of individual developers and a bunch of individual application teams that live in different cities and don't talk to each other a whole lot, as they make discoveries about, hey, if I use this function, I could save a lot of work, and if I use this one, there's a bunch of problems and it's annoying. That information today is going to be kind of siloed. But if you do this centralized approach with the centralized transformation definition, these learnings are upstreamed and they're shared with everyone, and it saves everyone some effort. So push campaigns versus pull campaigns. The way I think of a push campaign is you have this centralized team, they defined the transformation, maybe they got to a really good efficacy, 80, 90%, they're very confident that this thing works rather well. They can directly pull down code that needs to be transformed, transform it, and then push a PR to the application owning team to review. This way, you're putting less work on the application owning team. They don't actually even have to install the CLI or do anything. They just have a pull request that they need to go review and make sure it does what needs to be done. This is especially useful for things with high efficacy. For things that are a little more complex or trickier, or you just want to give the application owning team a little more ownership over, you can do a pull campaign where you have a centralized team, still create that consistent transformation definition, and instruct the individual application owning teams, hey, we're running a campaign to go from blah to blah. You have to do it. The deadline is this. So-and-so important person says you got to do it. But instead of doing it manually, here's a command you can just plug into your command line after you install the ATX CLI and run it on your code base, and it should get you most of the way there. It should take most of this work off of you. In our experience internally in Amazon, this has really helped accelerate internal migration projects because there's something to be said for the human nature of, hey, do something for me versus, hey, do something for me, and here's something I made. I put time and effort in to help you do it. So best practice number one, pilots. You're not going to know how well your transformation works unless you test it. You're not going to know how much it's going to cost unless you test it. You're not going to find the edge cases and weird little bugs and strange behaviors that your users may run into unless you test it. So highly recommend taking some time, maybe a couple of days to create your initial transformation definition, find some really good and meaty representative repos, and run it on those first. Then refine it. Tweak it, fix those edge cases, add exceptions when needed. You may need to decompose a really complex transformation into multiple steps. That's perfectly okay. I've seen customers use a pattern where they use our CLI syntax to invoke one transformation and then immediately invoke another one right after. Kind of just as easy as one transformation for a user, but for the agent, sometimes it makes things better if you give it smaller chunks of problem to focus on at a time. Learning items, knowledge items, which are discovered during execution, are not automatically enabled by default. That's to prevent any sort of malicious knowledge item being discovered and applied to code unwittingly. So the centralized team that owns the transformation is always going to be able to take a look at those and say, okay, the agent thinks it discovered something smart here. That's actually not smart. Let me not enable that one. And you can measure time and cost, and you can put together your automation mechanisms for using this within your organization. However you all store code and do code reviews, and it can slot into that. It's a really bare bones, easily build on top of a CLI. Script and automation and integration, I touched on most of this already, but here's an example of how simple the syntax can be. Git clone the repo, ATX exec n is the name of the transformation that's stored in your registry. That's been shared across your company. C is the build command, which is optional. Sometimes for Python and stuff, people use a linter or something for that. It's just a way to tell the agent, hey, here's how you check your work. If you run this, make sure you don't get 1,000 errors. If you did, you probably did something wrong. X is non-interactive mode, so saying don't wait for human input, just go. Sometimes I call it YOLO mode because it means the agent is not going to ask for any help, it's not going to ask for any approval, it's just going to go do the thing. T is to trust all tools. You can also configure tool permissions if there's certain tools you do or don't want your agent to use. And then it'll run, and then you tell it, okay, push the PR somewhere, and someone will review it. You can stick this in a container. You can stick this in a pipeline. You can stick this in an AWS batch job. You can stick this on a laptop in the basement. I don't particularly care. However you want to run your modernization campaign on whatever infrastructure you want to run it on, as long as it's got Node and Git and you can get your code onto it and it's Linux-based or Mac OS or WSL, you can put it there. So this is intentionally making it really flexible for however you like to work. What else? Yeah, GitHub Actions, GitLab CLI, all sorts of places that you can put it. Obviously, first-class integrations would be nice if we could say, hey, this already exists in a GitHub action, or if we had a pre-built container we can give you and say, go, just use this. We're getting there. And then I just also wanted to note the AWS Transform web application. So if you've used AWS Transform at all in the past, you may be familiar with this web application. This is where our mainframe modernization, our VMware migration, and our .NET modernization experiences live, the parts of AWS Transform that shipped a few months ago. ATX Custom is mostly CLI-based, but it does have some connections into the web app, namely campaign management. So if you are a program manager or a campaign manager or just someone whose boss is like, hey, you said you were running this campaign, I want pretty charts and graphs, how's it going? This is the place for that. So you can set up your campaign, you can see all the repos that have been executed, and I think we had a video for this one, right? Yeah, look at that. So I'm a campaign manager, I'm a program manager. I go into the web app and I tell it, hey, I need to upgrade all of my Python lambdas. What do I do? Is it playing? Nope. Ah, yeah, there it goes. I want to upgrade all my Python lambdas. The web app has full knowledge of every transformation that's in the registry, so those are the AWS provided ones, as well as ones that people in your organization may have created. It's going to pull down the relevant transformation. Whatever. It'll create a campaign. It'll give a command that you copy paste, you send to your developers, tell them, hey, go put this in your CLI, execute it. And as they execute it on their repo, it's going to save the results of that execution, like did it validate, did it succeed, did it fail, and give you that beautiful UI in the web app to see all this collective aggregated data. And because it is AWS Transform, you've got the agentic chat interface. You can chat with it about that data. You can say, hey, how many of these over the last month validated, how many did not? Any sort of way you want to slice and dice the information, the agent can help you with that. Customization.
Thank you, Morgan. So we looked at how you can transform a single repo. We looked at how you can scale it to multiple repos. What ends up happening is that every customer that we talk to really has organization-specific customizations that have to done there. This is why we called the product AWS Transform Custom. Even for things such as job upgrades, you have your own target versions, your own framework, your own ways that you want to do things. So when you have an AWS managed transformation, such as the ones that come right out of the box, you actually also still probably need to add some additional customization. Things about your organization-specific pattern, internal libraries, output style. You may want to have your own validation criteria, like a special integration test or commands that you want the agent to run to make sure that things are working properly. As an example there, when you're doing like a Python 3.8, 3.11, you may want to add an internal logging framework that you want to use. You may want to have specific error handling, that how things you want done in your organizations. So this customization happens once, but then the agent still continues to learn your organization-specific things every time that is executed. So developers that run it interactively and provide feedback, or ways that basically the agent finds that don't work or that do work, the agent will still continue to learn. Sometimes, though, you actually do need fully custom. And we talked about these things. There's organization frameworks. Maybe you have your own custom libraries or proprietary patterns. You have strategic migrations. You may want to change your authentication service, migrating from Auth0 to Cognito or vice versa, going from Splunk to CloudWatch or vice versa, and doing vendor changes. You may harmonize the tech stack across merger and acquisitions, or do architecture changes. There are multiple ways you can create custom transformations using AWS Transform. These are like some of the ways that we usually propose. One is the prompt and refine. You can start with a simple prompt. The agent will ask some questions about what you want to do, and basically after you have a first transformation definition document, you can iterate on it depending on some samples and your examples. You can also start with guidelines. You may have a migration guide that's already existing. If you have an internal framework, you may want to provide API specifications of the different versions, or very important, before and after code samples of how you want things to do. Finally, you also have a way to have it like do it with me, which is like a way in which you have like a very simple transformation definition, and you basically stop the agent while it's doing it, providing feedback. Very, very important is references, before and after examples, and after you're done, the idea is that you publish this new transformation definition on your organization registry that is associated to your AWS account. That is can of course be access controlled through IAM. Let's look at the demo for this. Okay, there we go. So here, as Morgan said, we can start ATX, here it's already installed, and let's say that I want to do something custom that is not available there. I want to add open telemetry tracing to my Node backend apps. I mean, this seems to be like a pretty common modernization thing. You may also want to change between those things. What the system is going to do now is going to go and look at all the transformations that are existing in my registry. We have a ton because this is our own internal account, but one of the things that I want to show is at the beginning is the list of the AWS managed ones with the description and what they are. So after that, the agent is basically going to say, okay, there's no existing transformation for adding open telemetry. It will help us create a new one. And it starts asking some questions. Say, okay, what kind of backend do you have? Are you planning to use a specific backend? And do you have some existing logging? What I want to say, okay, these are like mostly Express, and I want to use AWS X-Ray. And do I have any existing? If I do, I want to remove it. Okay, this is also the moment where it will basically ask, do you have migration guide, documentation, a whole bunch, and an example for doing like before and after, how do I want to do that thing? For open telemetry, what I can imagine is that you probably want to have, you may have your own specific attribute that you want to put, the kind of traces that you want to have, and probably you want those things to be consistent across all of the repos. That would be the moment to add all of those informations. Now, it's going to go here and it's going to kind of think for a little bit. And okay, I talked enough to give it enough time to do something. This is great. And it basically said, okay, this is the first draft that it came up with. Add open telemetry tracing to such and such. It has some entry criteria. It has some implementation steps. The idea is that this is a TD file. You usually run this inside of an IDE, so you can basically say, okay, this is my transformation definition. You can open it. You can edit the MD directly and say, hey, I edited it. Or you can ask to change something. There's implementation steps, and one of the things that is really important are the validations and exit criteria. It says, okay, package.json has all of these things. Some of those things may require for you to customize exactly what you wanted to test. You may have some integration tests. You may have to provide your own way to actually test X-ray integration, for instance. Or maybe you want to run some specific integration tests that are specific to your org. The idea is that you can look at it and you can now apply it and see what happens. You can review or modify. You can do anything like that. One of the things that I already did is that I used one of these transformations earlier to actually create, to add telemetry to this Node REST API, and I created a diff in this file here. So what I'm going to do now, I'm going to go and say, okay, I want to modify the transformation to use these samples as references. Okay, and if the demo god are with us, they're basically going to say, okay, this is a file. I'm going to take it. I'm going to add it to the demo. And basically, what this is doing is looking at these files that can be multiple files, could be APIs. And what it's doing is it analyzing, is creating it and ingesting it into its own knowledge base. And it's also going and updating the transformation definition document to include the learnings from those files. Now, this is if you have things already available. You can, of course, run it interactively and basically saying, okay, I would like to do to basically give feedback directly when it's running on a specific code base. Now, this is going to create a TD. I'm not going to wait for it to finish. After it's finished, you can publish it and you can run it like Morgan showed before. This can be, here is still like working. It's adding summaries and it's doing like a lot of other things. Now, let's say that I have this thing and we want to run it. Let me Julia Child this thing a little bit because this is going to take some time. Let's say that I run it on this specific application, And what we see here, we see the transformation definition, it has the entry criteria, and it has a set of validations. After I run it, what it does, the system provides a validation summary, given all the validation criteria that I provided. So it tells me, okay, this is what I did, this is what happened, and the overall status was partial. It wasn't able to validate everything, but it tells me why. 8 out of the 10 fully passed. 2 criteria were partially met because I did not give it any information on how to actually test X-ray. I wanted to go and see that things were in X-ray, and of course I didn't give it any information to do it. This is really important if you want to automate these things at scale, because one of the things you don't want to do is for agents to fail silently, to basically say, okay, I did it, and then you have stuff that's not working. Because then that basically means that all of the ones where it tells you that are completed, you have to go and recheck everything. You want to make sure that validation is specified as precisely as you can, and that will make sure that you can automate things and really have the savings that you can have. This is the validation summary. After it's done, a really nice thing, we do require Git in all of these, for all of these transformations. And if you go here, you see that it created different commits in its own branch. So you can have every step that is in your transformation definition, that is in a specific plan that is being created to apply the transformation to this thing, you have a different step that is committed here. And you can see and review exactly what happened. So the first thing that it does, which by the way was in the transformation definition, was to add all the packages, as you imagine, and it created a new JavaScript file with a tracing configuration for AWS X-ray. And this is the common file that is used by all the applications. Usually, you probably want to provide something that is very organization specific. You want to say what it did. Then it went and said, okay, these are my route handlers, data access. Let's look at like data access. You see here, there's a lot of things that were added. From like orders create, all this green is basically all the open telemetry spans that add the various attributes, or order.userid, order.category. And all of these things are probably things that you may take like a first stab as it proposes, but you probably want to provide something that aligns to your own patterns and organization-specific things. These are the usual things that are specified in how do we want to integrate open telemetry in our code bases. You give that to the agent, you're going to make sure that all of the things, all of the code bases in your organization follow the same patterns. You can also instruct it to detect divergences. A nice thing here is that you can also, when we talk about this, okay, this added, I have my updated transformation, I can publish it. One thing that is really interesting here, and let me actually start a different conversation. The agent knows what are the things that it's good at. So if I say something, can you transform .NET applications into Java? This is a hard thing. And the thing is that you want the agent to know the thing that it knows how to do. It will basically tell you that, well, okay, this is a very high complexity transformation due to the significant differences. So you can still try to do it, and it will basically tell you what kind of things you can, you should think about when you want to do those things. If you want to separate it between extracting specifications, if you want to use Strangler Fig, but basically it knows the things that are easier or not. Now, let's go back here, and let me go back here to my PowerPoint. Here we go. So what we have here, that was the open telemetry, is a code refactoring, is one of the transformations that is one of the sweet spots that we have. Code refactoring, library upgrades, runtime upgrades. We've been dealing with those kind of transformations for the last couple of years in AWS Transform, and we know that the tool is designed to do it. But you will come up with new things. We've had Customers come with us with very, very strange things, and sometimes they were able to be done very, very quickly, and sometimes they required a little bit more complex setups. How do you improve the transformation quality? How should you think about it? The quality of the result depends on two things. One is the complexity of the transformation. Like .NET to Java, really hard, two different languages. It can be even harder, like C to Rust. Like it can be really, really hard. The other thing is the input code base. You may have a .NET to Java app that is 800 lines of code, may be able to do it right away. But even an easy transformation, even a Java upgrade applied to a 5 million lines of code base with multiple modules and tons of dependencies, it may still struggle. So we continue to validate the transformations in our sweet spots. We have a ton of internal evals on internal code bases, open source, and we always make sure that we improve that quality. But you still need to have some improvement strategies. And there are some of these things that you can do at definition time. Providing high-quality documentation and code samples. Running pilots, super important. After the pilot, you'll usually tend to have a lot of before and after examples of things that you want. So the agent can really learn a ton about those things. You also test it, continue learning in order to make it work better. You can decompose the transformation, like Morgan was talking about before. For instance, if you want to translate across languages, you can first extract specifications, then do code generation. You may decide to decompose based on functional layers. Some of our customers said, okay, let me first migrate the data layer. Then I want to migrate another layer. So on and so forth. During refinement, we talked about the pilots. You want to understand what kind of results you can have, and if you're seeing that you're not getting the quality that you want, then is the moment where you have to reevaluate and say, okay, this is a really complex transform. Let me decompose either the transform or the targets. Let's talk about value and pricing. The customers that we work with in the last 6 months reported 3 things that they were really happy about. On one hand, they were, of course, the direct time savings. It was faster than doing things manually. It was faster than just using a general purpose coding agent. They were able to run it at scale. The other thing was it enabled things that they thought that they were deprioritizing because they were too expensive. The Twitch team was deprioritizing doing the AWS SDK migration for this year because they did not want to spend 11 dev years. It seems a lot, but fundamentally what it says is that, okay, we're going to work on a year for a team with 11 people. It's possible, but it's not something they really wanted to do. The other thing that was there was quality and consistency. Having consistency across all those 900 repos, or in case of like Air Canada, like thousands of Lambdas, was really critical. Most of these things are driven from centralized teams, and consistency is really important. They're usually in charge to make sure that things are consistent across the code base. And of course, they really saw continual learning improve the quality and compounding value. How do they measure it? There's, of course, efficiency. How fast did you go? Quality metrics was also important. How many things had to be reworked? When we talked about an efficacy rating, 90+% of code bases for Air Canada did not have to be touched by anybody. That code was reviewed and sent to production. 10% still had to be, tweaked. But that is like, there's a very big difference just taking a PR, testing it, and just flying through your validation versus having to tweak and understand and figure things out. And then there's business impact. There's cost reduction. Think these are operating costs. You may have going to more modern frameworks may actually save you money, less resource utilized, better advantages. Risk reduction. You may have you're on the latest versions, more reliability, less security risks, and of course, strategic enablement. You want it to be on certain frameworks, so there's usually a reason. This is generally available. It's available in US East 1 today. And we're going to add all the other AWS Transform regions in Q1. We are in 8 regions. We do have cross-region inference, but they are geo-related. So North America, Europe, and like things like that. The pricing is pay-as-you-go, as Morgan was talking about. It's 3.5 cents per agent minute. What's an agent minute is basically how much. It's a notion of the amount of work that the agent takes. You only pay for active agent work. So if the agent is waiting for your code base to compile on your thing, you're not paying for anything. If you're waiting idle because the user is like waiting for something, of course you're not paying anything. However, multiple agents maybe collaborate to do your transformation. So 15 minutes of wall clock time on the server side may actually result in a charge of 20. We have some examples there, and that's why we suggest to run pilots on your own specific transformations to have an idea. However, the cost is small enough that it should not be hard or prohibitive to try these things. You can always interrupt. You're in full control of how much you spend. What we suggest you to do, and what I incite you to do, guys, is that to build confidence through progressive learning. It's hard to use AI to do these things autonomously. It's kind of a step level from using an agent interactively. What we suggest to do and what we've seen successful is basically to start with things that are simple and already provided by AWS. One low risk and high value way it is to start with documentation. You can learn the workflow. You have no code changes, so there's no risk of like messing anything up, and you can build familiarity with the tools. You can then go on AWS managed transformations. Every customer we talk to have problems with runtime upgrade and end of life and SDK upgrades. This allows you to learn the end-to-end workflow, to experience continual learning in actions, customize this thing, tweaking them for your own specific organization, and you can start measuring savings and see what you can get with this technology. You can then move on to simple custom transformations. Think about logging, adding open telemetry, trying to modernize things from that perspective. In my experience, every company that I talk to has one of those backlogs hidden in their issue trackers. And finally, you can move on to more complex custom transformations in the context of larger modernization, architectural changes, language changes, and things like that. So there are some resources here. You can learn about AWS Transform Custom on our website. There's a hands-on demo. It's super easy to get started with the CLI. No complex setup needed. Runs on your laptop, basically. Well, it ran on mine. I'm really happy that you guys chose to spend your time here with us today. I'm really looking forward to see what you guys can build with this technology and what kind of transformations you can do. Thank you.